So this is the last video for systems of equations. Now, for the students who have been in class, which is most of you, this is just designed as a quick reminder. For those of you that were sick or not at school the other day, this is designed to help you out with getting caught up. But I realize that it may not be close to enough because this is your first try at this. So please email me using the contact form at the front of the website at the home page for more examples if you need it or any questions. Or you can save it till class if you're going to be back in class. So we're going to look at the elimination method. And that's your I can statement. It's to solve systems of two equations using elimination. This is synonymous with addition method. Some people may even call it the subtraction method. You can add or subtract two equations. So I just use the word elimination because that's really what happens. Here are the steps written out in words. And this, by far, I think, is the newest part. You guys kind of already would know how to do step 2 and step 3 because of your past knowledge. But step 1 is really the main new part of this. And so if you want to write these steps down, pause it. But preparing the equations to be added together or subtracted, I should have said added or subtracted because you can add or subtract them. That's the part that may take us some time. And the goal is to eliminate one variable. So let's go to that first. So I've got these two equations and I want to use elimination. I want to eliminate either the x's or the y's by subtracting or adding both of the equations together. So what I'm going to do, I think, is multiply both equations by a number to get two opposite coefficients. In other words, I think I can make this a negative 15x, and I think I can make this a positive 15x. So when I add the equations together, x's go away. Let me show you what I mean. First, you have to realize it's totally mathematically fine to multiply or divide everything in an equation by the same number. So in other words, I'm going to multiply everything in this equation by negative 5. And then I'm going to multiply everything in this equation by positive 3. Because my goal was to get this to a positive 15x, and you get this to a negative 15x. So when I do the multiplication, I get the following. Same over here. I'll get 15x minus 15y equals 30. So two things here to keep in mind. First off, the fact I chose the reason I chose this to become a negative 15x and this to become positive 15x is just for the sole benefit of when I add them together, they'll go away. I could have tried to make the y's go away, but I just chose to make the x go away. So one of the challenges with the elimination method, or really the substitution method, is there's so many different ways you could go about it. And so realizing these examples, I'm just going about it one way. And there may be a faster, more efficient way that I didn't see, that you guys would see. Or you could go about it a different way and still get the same answer. That's fine, as long as you don't break any math rules along the way in the process. So I ended up with some opposites here. So I can record both equations again. I'm going to copy this one here in the top part. And then I'm going to copy this equation here underneath it. Negative 15x plus 10y equals negative 10. And now that I was successful in getting coefficients that are opposites here, I can add both equations, and you guys know that a 15x minus or plus a negative 15x gets us 0x. So I have no x's, so these kind of cancel each other out. But a negative 15 plus a positive 10y leaves us with negative 5y. And then a positive 30 plus a negative 10 is 20. So as you can see, when I added these equations together, my x's canceled, and I was just left with this. And now it's very easy to solve for y. Y is negative 4. And then I come back to the next step, and that would be the same as in the substitution method. I would plug in my y value into one of the original equations to calculate x. So let me copy one of the original equations on the next slide. Let's use this one. 5x minus 5y equals 10. Okay. And over here I said y equaled negative 4. Okay, so that's what I got. So I'm going to plug that in. 5x minus 5 times negative 4 equals 10. Or 5x minus a negative 20 equals 10. And we'll we know that this becomes a positive 20. And so we're left with x equals negative 2. And if I lost you back here, what I did is I moved this positive 20 to the other side. So subtracted 20 from both sides, and 10 minus 20 is negative 10. And so I get an idea here of, or a solution of x equals negative 2. So my solution for both of the equations should be negative 2, negative 4. But just like in the other methods, I don't want to take that for granted and think it's right. I want to check it. So I'm going to copy down both equations again and double check myself. Because if you're like me, you make mistakes. I think everybody does. And so this is what I thought was the solution, negative 2, negative 4. And let's plug them in and see. And what I'm doing here is I'm just inserting x and y for the variables, and I'm going to see if I get true statements. So I'll simplify the one on the left here first. And so I get a true statement. And if you're wondering what happened from here to here is 2 times negative 4 is negative 8, and minus a negative is positive. So negative 6 plus 8 is what it's simplified to. And I get 10 equals 10. So this is indeed a solution. And I've checked it because it works for both equations. It gets me to true statements. Quick recap for you. Let's go all the way back here. This right here, I think, is the hardest part of this method because it's the newest. I chose, somewhat arbitrarily, that I wanted to get rid of the x's. I could have just as easily gotten rid of the y's. And I decided to add my equations together. I could have subtracted my equation, that's fine, but it wouldn't have got me 0 x's. So what I did is I decided to make this negative 15x and this positive 15. So when I added them together, I would get 0x. And you can multiply any equation by any number or divide any equation by any number as long as you do it to everything in the equation. And so I used all of those tricks and rules and stuff to get rid of x, just isolate y. Then I used what it said y equaled to solve for x. Then I checked the point against both equations. I hope this was helpful for you. Good luck to you.